Today, let us look at the nth term of an arithmetic progression. Let us consider an arithmetic progression with first term 3 and common difference 2. The first term is 3, so the second term would be 3 plus 2 or a plus d, which is 5. The third term would be 5 plus 2 or a plus d, which is a plus 2d. The fourth term would be 7 plus 2, that is a plus 3d, and so on. Now notice the pattern. For the second term a2, we are multiplying the common difference 1 less than 2. Similarly, for a3, we are multiplying common difference with 3 minus 1. So for the nth term or an, we would be multiplying the common difference with n minus 1. So my nth term would be a plus n minus 1 times d. An represents the nth term, a represents the first term, and d represents the common difference. Let us look at a few problems. Find the number of terms in the given AP, 7, 13, 19, so on till 205. Now here, the first term is 7, that is a, and the last term is 205, that is an. We can also see that the common difference, which is the difference between any two consecutive terms of the AP, is 6. Now here we have to find the number of terms. Can you think of a relationship between an, a, d and n? Yes, we just learned the formula. So let us write an equals a plus n minus 1 times d. Let us substitute the values and solve for n. We get n equals 34, which means that the given AP has 34 terms. Let us look at another problem. If the third and the ninth terms of an AP are 4 and minus 8 respectively, which term of this AP is 0? Now the third term, A3, is given as 4. And the ninth term, A9, is given as minus 8. And we have to find the term 0. So we are given an equals 0 and we have to find the value of n. Now we know that an equals a plus n minus 1 times d. Let us apply this formula to a3. So we get 4 equals a plus 2d. Similarly, let us apply this formula for the term a9. We get minus 8 equals a plus 8d. Applying the formula for an equals 0, we see that to find n, we would need to find a and d. Now we already have two equations with the variables a and d. So let us solve these two equations by the elimination method. Eliminating the variable a, we find d equals minus 2. Putting this value of d in one of the equations, we get a equals 8. Now let us substitute the values for a and d in the third equation that we wrote for an. Solving for n, we get n equals 5. So fifth term of this AP would be 0. Let us look at another problem. Determine the AP whose third term is 16 and the seventh term exceeds the fifth term by 12. We are given the third term A3 equals 16 and the seventh term exceeds the fifth term, which means that the seventh term is greater than the fifth term. So A7 minus A5 is given as 12. And we have to determine the AP, which means that we would need to find A and D. Now let us apply the formula for the nth term. Let us apply this for A3. So we get A plus 2D equals 16. Similarly, applying this formula for A7 and A5, we see that it gives a solution for D. It gives us D equals 6. Substituting this value in the first equation, we get A equals 4. Now we can easily determine the AP. The first term is 4. The next term would be 4 plus the common difference, which is 6. 4 plus 6 gives us 10. The next term would be 10 plus 6, 16. The next term would be 16 plus 6, and so on.